Today's topic is something called factorization. Before we begin, I want you to realize something. This is on page 54, of course, of your booklet. But something to realize is that we are basically going to be doing the opposite of expanding brackets. So I want you to have this image in your mind. This is what our answer will kind of be looking like, depending on the type of problem that we have. We might have something that looks more like this with the x outside, or something with just some number and then some brackets. What we're trying to do basically is go from something that looks like this and place it into brackets just like we had before we expanded. So some notes I want you to take maybe on the top of your sheet is that expanding brackets is the opposite of factorization. So hopefully by the end of this, you'll kind of see why that is. But the format is basically we're going from something that looks like this, and we're going to place it into brackets, all right? So in order to do that, what we need to do is find something called the common factor. And actually, I'll call it the highest common factor. This is something that you've probably seen at least in year 7 and even before then in primary school. However, since we're working with algebra, there are going to be two pieces or multiple pieces of the common factor. You have first the number. So first we'll look at the number, and you'll just find the highest common factor of all of the numbers that are involved in each term of the algebraic expression. So for example, let's just take a look at this first problem. If I have this is my first term, 6x, this is my second term, looking at just the numbers, the highest common factor of 6 and 2 would be 2, right? So we would keep that in mind. We would use that for our number bit of the highest common factor. And then we also have the letters, the variables. I'll put letters below that. Now this is something that we haven't really seen before. In order to find the highest common factor of two variables, what you'll need to do is search for the lowest power that you see, or the lowest index that you see. I'll put index / power depending on what word you're comfortable with. And so when we try our first example, I'll kind of show you what I mean there, but you're always searching for the lowest power, and then you'll use that to pull outside of the brackets, okay? So let's take a look at this problem number 1. All right, so keeping in mind that we have two pieces to finding our common factor. If I'm looking at 6x take away 2, I have two different terms there, right? They're separated by that minus symbol, 6x and 2. So maybe I'll use the different colors. I'll use green for number. Looking at the numbers in each term, I have 6 and I have 2. I want to find the highest common factor of those two numbers, and that would be 2. All right. And now we're looking at all of the variables. There's only one variable in the entire expression, and that's that x right here, okay? But this expression has no x at all, okay? So since this expression or this term does have an x and this one does not, there's no common factor involving x there. So we do not need to include x as part of our common factor. So this would be the common factor, just 2. And then what we need to do to figure out what goes inside of the brackets is take each individual term and divide that by our common factor. So my first term was 6x. I would take 6x and divide that by 2. 6 divide 2 is 3, and then x divide no x is x. So that's going to be our first term. And then we'll take the second term, which happens to be a minus 2, and we'll divide out this positive 2. So I have minus 2 divided by 2, which gives me a minus 1. So that's going to be our second term inside of the brackets, okay? If you've never seen this before, you might be slightly confused at this moment, but here's why that is our answer. That's why this works. If we go backwards and we expand our brackets here, what we would do, right, is multiply 2 times 3x. 2 times 3 is 6, along with the x gets us back to 6x. And then I have 2 times minus 1, which gives us back to minus 2. All right, so essentially what we're doing here is working backwards. We're trying to go from this end result expression, normally what we had before when we were expanding the brackets, and we're trying to go backwards into our brackets, I guess. So we're working backwards, and this is called factorization because we factorized out what we call the highest common factor. So the highest common factor was 2, and that goes outside of the brackets. Let's work a few more examples together. Okay, this might take a little while to get the hang of. It's a little bit challenging at first, but I think once you get the hang of it, it comes quite naturally. So again, looking at the two terms that we have, 8x and 14, if I'm looking at just the numbers first, just the numbers, I have 8 and I have 14 from this term. The highest common factor, the highest number that goes into both 8 and 14 is 2. So again, our factor will be 2 on the outside. And then looking at the letters again, I just have x here, and I don't have an x term in that second term, so we will not factorize out x. Basically, both terms need to have the same letter if you're going to factorize that outside of the brackets. So what we do from there is divide each term by the factor that we just pulled outside of the brackets. So I'm going to take 8x and divide that by 2. 8 divided by 2 is 4. And then x divided by 2, or x divided by no x, I guess you would say, is just x. So that's our first term. And then for my second term, I have positive 14 divided by my factor on the outside. So positive 14 divided by 2 is positive 7. Let's double check to make sure that if we re-expanded this out, that we would match our original given expression. I have 2 times 4x, which gives me 8x, and then I have 2 times positive 7, which is positive 14. So that looks correct. That would be our answer. All right. I might let you finish C, D, and E on your own, and I want to take a look at question 2, because here we're starting to see variables of different indices, and that will change things a little bit for us. Actually, none of these have a coefficient or number out in front of the variable, so we don't need to worry about the number part of the common factor. So on question number 2, we will not be worrying about this number bit of each problem. We'll only be worrying about the variables and the letters. So I have 2 terms in question A. The first term is x squared. The second term is x. We want to choose, remember I said we want to choose the variable with the lowest power, all right, to bring outside of the brackets. So I see a power of 2. This is an invisible power of 1. So this is what I'm going to choose to bring outside of the brackets. And then I'm going to see what's left over if I divide everything in my expression by the term x. So the first term was x squared. I'm going to take x squared and divide that by x. X squared, divide x. Remember, we subtract the indices. So you have 2 take away 1 would give us x to the power of 1, but you do not need to show the 1. And in fact, please do not show the 1. That is just a little bit unnecessary for us. For the second term, I have just x. So I'll divide that by the term that I pulled outside of the brackets, which is also x. So x divide x, anything divided by itself is 1. And it's a positive 1, so I need to put a plus 1. I have my 2 terms that I pulled from up here, x plus 1. That is our answer. Let's double check by re-expanding that out. X times x is x squared. And then I have x times 1 is plus x. All right, there's our answer. We're finished. Okay, let's jump down to one that's a little bit more complex, maybe that last one, a to the power of 7 plus a to the power of 4. So just like I said, here are our 2 terms. Remember, for the variables, the highest common factor is the lowest power that you see. So if I have a to the power of 7 and a to the power of 4, 4 is the smaller number. So that is the power or the index that I'm going to bring outside of the brackets. And then I want to see what happens or what's left if I divide both of these terms by a to the power of 4. You can show it like that if you like. Essentially, that's kind of what you're doing, is dividing out by the common factor that we chose. So a to the power of 7 divided by a to the power of 4. Remember, when we're dividing variables with the same base, we subtract their indices. So 7 take away 4 would give us the power of 3 for a, for that first term. And then I'm just going to bring over this plus symbol. And then we have a to the power of 4 divided by a to the power of 4. These two things match. Anything divided by itself is just 1. Okay, let's double check our answer to see if we feel good about that. A to the power of 4 multiplied by a to the power of 3, add the indices. 4 plus 3 gives us 7, that looks good. And then a to the power of 4 times 1 would give us a to the power of 4. So that is correct. All right, just be sure to check your answers. I think that's a good idea. And I think it will kind of help you understand why we're doing what we're doing and how we're doing what we're doing and how to get there. If you check your answers, you can't go wrong, basically. Okay, question 3 starts to involve both numbers and letters, okay? So we'll need to kind of separate them out. Remember, the common factor bit, we have the number and the letter. It might have a combination of both. So in section 1, we only had numbers. Section 2, we only had letters. Section 3, now we'll have both numbers and letters involved. So I'm going to choose the numbers in green again. Looking at just the numbers, the coefficients, or the numbers out in front of x, I have 3 and 6. Looking at just those numbers, the highest common factor of 3 and 6, or the highest number that goes into both 3 and 6, would be 3. All right. And then looking at the letters of each term, I have an x squared, and I have an x. Remember, for the letters, we want to choose the lowest power that we see. So the lowest power is this x to the power of 1. So I'm just going to factorize out an x. And then we will have our brackets and divide everything out by 3x to see what's left over. So for our first term, looking at the first term, I have 3x squared, and I divide that by the common factor that we chose, which was 3x. So if I'm looking at the numbers first, 3 divided by 3 is just 1. We don't really need to show that. You could put a 1 there, but we're smart mathematicians. We don't need to show that that 1 is there. Mathematicians are lazy, and they don't like to show that extra 1 because it is unnecessary. All right, the next bit is the letters. I have x squared divided by x. Really, that is an x to the power of 1. Remember, we take away our indices. 2 take away 1 would give us x to the power of 1, or we're smart as well. We don't need to show that invisible 1. So for the first term here inside the brackets, I have just x. I'm going to bring over this plus symbol. And then my second term, I have 6x, and we divide out the term that we pulled outside of the brackets. Okay, so 6 divide 3, we know is 2. X divide x is 1. Since I already have this 2 here, I don't need to show that extra 1 because 2 times 1 is just 2. Okay, so this is our entire answer. Let's do a really quick check. 3x multiplied times x would give me 3x squared. And then I have 3x times 2 is plus 6x. That is correct. Okay, that is your answer. Let me see. The rest of those are pretty similar. I will say on example E, 7 and 8, those two values do not have a highest common factor. So you would only pull out x here. All right, you would only pull out the variable x, and then you would have 7 left over plus 8 something, but you would divide x cubed by x would be x squared, and then x divided by x is nothing. So your answer would just look like that. There might be a situation where you do have two numbers, but you cannot find the highest common factor of them, so you kind of just leave it without the number, and then the numbers will stay inside the brackets. All right. Let's work a couple of more challenging questions from problems 4 and problems 5. Okay, notice we start to involve multiple letters at a time here. I think I'm just going to choose maybe 1 or 2 really challenging examples, and then I will let you get on with the rest of the worksheet. Let's look at question D, because we have 3 variables involved. All right, you have your letters. I have 16. And then I'm going to try to use as many different colors as I can. I have a squared and a there. I have b cubed and b squared. And then I had another purple pen. I have c to the power of 4 and c cubed. Okay, so we want to look at each group individually. The A's go with the A's, B's go with the B's, C's go with the C's. But looking at 16 and 3, there is no value higher than 1, at least, that goes into both 16 and 3. So for the numbers, we're not going to have a common factor that we bring outside of the brackets. So here are our brackets. And here will be our common factor. All right, now let's look at the A's. For the A's, remember we find the lowest index, or the lowest power, okay, the lowest power. So I have a to the power of 2 and I have a to the power of 1. I'm going to bring out a to the power of 1 since that is smaller. And then I have b's, b cubed, and b squared. B squared is the smaller power, so that's what I'm going to bring out. And then I have my c's, c to the power of 4 and c to the power of 3. Since power of 3 is smaller, that's what I will bring out. Okay, so this gets a little bit complicated because we're going to divide each of these terms. I'll try to write it out very clearly, dividing each of these terms by the common factor that I just found. All right, and then we'll put whatever comes out of that inside of these brackets. So my first term was 16a squared b cubed c to the power of 4, and I'll divide all of that by the common factor that I just found. This is coming from here. Okay, when I'm dividing like this, I like to kind of make columns. So 16 is on its own. The A's go together, the B's go together, and the C's go together. And then we basically just want to subtract the indices for each letter. So 16 divided by 1 essentially is 16. I have a squared divided by a to the power of 2 divided by a to the power of 1. 2 take away 1 is 1, so we just have a. And then I have b cubed divided by b squared. 3 take away 2 is b to the power of 1. And then c to the power of 4 divides c to the power of 3. 4 take away 3 is also 1, so I'm just left with 16a, b, c. That was just my first term, right? And then I need to figure out what the second term will be, which I'll do in a different color. So this is the second term. So I'm going to add on some separate piece for the second term. All right, my second term was 3a b squared c cubed. I'm going to divide all of that by the common term that we pulled out at the beginning outside of the brackets. Okay, so I want to do a column around the A's, around the B's, and around the C's and see what's left over. The 3 is on its own. 3 is divided by 1, which just leaves us with 3. A divide A, these will actually go away because this is power of 1, power of 1. If I take 1 minus 1, that's 0. A to the power of 0 is 1. Or you can just think of the A's canceling out. Let's see, same thing with the b squared. Is that correct? Yes, b squared, b squared. Those will cancel each other out. 2 take away 2 is 0. B to the power of 0 is nothing. It goes away. And then c to the power of 3, c to the power of 3, those will also cancel out. So actually, we're just left with 3 for our second term. Okay, let me rewrite our answer there. This is still for letter D. This is a very long question. For question D, our answer ends up being a b squared c cubed brackets. Inside the brackets, you have 16abc plus 3. All right, and that is your final answer. If you wanted to, you could go back and check to see if it expands out to become this same exact expression, but just for the sake of time, I'm going to keep moving forward. All right, if you need to, now's a good time to maybe go back and rewind and watch that again because it is very tedious. Look at all of that working out that I've done. You won't always need to show all of this, but I think since this is an introduction, it's good for you to see all of those little mini steps. I would also maybe pause the video at this point and try these questions before I move on to an example from question 5. Okay. All right, so question 5. Here we're going to see an example. Let's see, I'll work question E. We'll just go for the toughest one. C, we're going to work an example where this first term might have some pieces that the second term does not have. And what I mean by that, see what I'm circling? I have x cubed here and x here. I have y in the first term, but the second term has no y. So we'll see what happens there in just a moment. And then in the first term here, I have z to the power of 4 and z squared. Okay, let's look at the number values that I circled. Those are the values in blue. I have 24 and I have 10. I want the highest common factor of 24 and 10, and that will be what I bring out in front to be my common factor. 24 and 10, let's see, is 2 the highest common factor? 2, I guess so. So 2 is the highest common factor of 24 and 10. And then x cubed and x. The lowest power that I see there is just x to the power of 1. The y's, since I only have a y in this first term, I do not have a y in the second term, I cannot factorize that out, okay? I guess that's kind of what we saw in question number 1. Keep in mind, we only had x in the first term, but not the second term, so I did not factorize out any x. Same thing will happen here. I only have y in the first term, not in the second term, so I do not bring out y as part of our common factor. This guy has a y, this guy does not have a y, so y is not common between the two terms. And the last one, z to the power of 4, z squared. The smaller power is z to the power of 2, so that's what I'll bring out. Okay, I'm going to divide now. So for my first term, I have 24 divided 2 is 12. X cubed divide x, I'm going to move kind of fast here, is x squared. Y divided by no y at all would leave us with y, be careful there. And then z to the power of 4 divided by z squared is z squared. All right, I'm just going to bring down this minus symbol to separate the two terms. And then I have 10 divided 2 is 5. X divide x goes away, that becomes 1, so we don't need to show it. And then this will happen again, z squared divided by z squared also becomes 1, so we don't need to show it because 5 times 1 times 1 is still just 5. So that will be your entire answer for that last question. Okay, so hopefully that came out all right for you. If you need to go back and rewatch from the beginning, I would understand. This is kind of a difficult concept at first. Sorry, I got all tongue twisted there. It's a difficult concept at first, but I think the more that you practice, make sure you practice each and every single one of these questions on the sheet, and you will become a factorizing pro. As usual, please email me any questions that you have. I'd be happy to walk through some more examples if necessary. Thanks.